Danielle, it's good to see you again. Thanks for taking some time to talk with me about another pretty interesting topic.
Nice to see you, Joe. It's been a while, and yeah, I know we've been brewing on this one for a little bit, so I'm very excited.
Yeah, so today I think you and I were chatting a little bit beforehand, and I think maybe one of the things that would be excellent to talk about is when should you automate and when should you not automate? And I think it's an excellent topic. And so I don't know if you want to kind of dive right in, but first things first, to set some kind of groundwork, like what is automation and what is robotics and how do they exist together?
Automation is pretty much any mechanized and or software task that the sort of hardware, software, or integrated system. So anything that a machine or software, software is a machine in a way, anything that a person used to do that now that actual labor task can be done with a machine. So it can be as straightforward as picking up a box and putting it down, or sort of more high level complex in the software realm, something like batching together orders and making an intelligent decision about how orders should come out and where they pick and that type of stuff. So anything where a person is no longer actually doing that task and a machine is doing it. So pretty sort of robust definition in there. We can get into more detail, but anything I missed, Joe?
No, I think that nails it. So what's the difference between automation in general and robotics specifically?
Right, right. So, great question because they often get confused. So let's see. All robotics are automation. So automation is sort of this bigger term, and then inside of the world of automation, there are different subsets, right? So robotics is a portion of automation. So again, all robotics are automation, but not all automations are robotic. Robotics is like a certain type. So if you think like there's a bunch of tomatoes out there, right? And that's automation. And one type of tomato, like a Campari, that would be robotics. It's the summertime. It's the summertime, and I just harvested a bunch of tomatoes, so they are on my mind. So hopefully you guys are also harvesting your tomatoes out there or eating some, but I know it's like tomato season. So that's why the very weird metaphor there.
Perfect. Okay. So now we kind of have an understanding. Like the machines are going to do it for us. We want to automate, but it's not always appropriate to automate. So I think, and we get this question a lot at Hy-Tek. When should I think about automating? If I'm walking through an operation, what am I looking out for? What am I like paying attention for? What am I checking in the data for to tell me that maybe this is something I should investigate for automation, or maybe I should not be looking at automation for this particular scenario?
Yeah, the first thing that I usually look for is repetition. So anything that's happening multiple times back to back, and in a less pointed way, anything that's boring. So that can mean if you imagine yourself doing something for 8 hours a day, no music, no talking to people, you are simply in a box, sort of doing the same thing. That's usually a low hanging fruit to pop out for where to automate. What do you usually look for?
Yeah, so I like any type of a repetitive task. Sometimes it's hidden what those repetitive tasks are, but if I see a lot of people in an area, um, right, typically that's a giveaway that's like they're having to do something a lot with hands. Or if I see a lot of labor hours, like in a data set, like hey, there's a lot of people that are having to touch this process. Maybe I don't see them on the floor, but for whatever reason, like they're doing that a whole lot. That's a big one for me. One thing we're seeing a lot is, and the lack of like staffing problems are kind of the negative of this, but maybe you can't see them. But when you look at their process flow, it looks like pretty straightforward process, like mash button 15 times, right? Or, you know, unfold box, like tape bottom, unfold box, tape bottom. They don't have anybody doing it. We're finding a lot more cases where there's just not people to do the repetitive tasks and there's nobody there. So there could be a bottleneck building up around it. It's sort of like that other symptom that you might see. Some of the other ones, and I think you had mentioned some of these maybe on some of your past projects, but sometimes maybe the task is not super repetitive, but it's kind of dangerous, or it might even be like physically like very, very difficult to do.
Yeah, heavy. When something is big, heavy, or like when you have to wear a lot of PPE to simply exist in the space. So heavy is really straightforward. Picking up a 60, 50 pound box, something like that, repetitively is going to be terrible. Additionally, if you're ever having to wear some sort of like breathing protection, that is usually a really big cue for me to say, get that human being out of there. That's a really, really straightforward one because robots and automation don't necessarily breathe. If you see anyone wearing a mask, not for like safety or like COVID reasons, but if you see someone wearing a true respirator, that is one thing where I usually go, oh, that's a great choice for automation. Anytime you see someone wearing a respirator for dust or paint, fumes, concrete, metal.
People have to dress up, have to maintain like minimum amounts of out time if they're pulling the material out, or like they can't stay in there for too long, and it's hard.
Additionally, on the flip side, if it's very, very hot, in certain, especially when it comes to like forging or other metal processes,
Oh
or
yeah.
even in certain parts of the country, I just did a bunch of installs on the East Coast during the summer. It was very warm. It was not enjoyable. It was very hot and humid. Um, and any place that it's just environmentally out in the sun, any place that it's very warm, anywhere where humans really struggle to be in consistently.
Okay, so basically, we're saying like if people don't really want to or aren't built for it, like we should probably think about automating. So if it's super boring, people get bored really fast, or if it's
Well, then,
a dangerous, like rough place to be, then yeah, let's look at a little bit of automation, a little bit of robotics. It goes a long way. Okay, so kind of some real world examples. I know I talked about some frozen situations, right? Like maybe you have a whole bunch of food in a warehouse. You're going to keep your full pallets back there and maybe pull some out for processing with something like a two-way shuttle or an ASRS crane. Robotically speaking, like I've seen a lot of paint booths that are like 6-axis arms running around. What are some of the less visible robotics applications you've automated where like it wasn't quite as obvious how impactful that was going to be?
yeah, I'm working on one right now that is doing a machine tending application for plastic. The plastic pieces and the injection molding they get very, very warm. Like the person working in that area has to basically be inside of the machine pulling out these little uh, home improvement knives, putty knives type of thing. And they have to wear big gloves to make sure that they're not too hot. It's really dull. So that's one of the ones where it's not a freezer. It's actually too hot. And that was surprisingly a huge, they want another system. So it's like, it's very, very effective. So now that a person doesn't have to be constantly changing out every 1 to 2 hours because they have to wear these big leather gloves with a leather uh, apron on inside of a very hot warehouse. So in the summer months, they truly do have to rotate whoever's working that station about every hour because of the humidity and the gear and that type of stuff. Another one that you wouldn't think about is to that respiratory note is filling up bags of concrete. The concrete fillers and they give off quite a lot of dust. It's not rated for you as someone with lungs, as a human with lungs to be in. So you have to wear a respirator and you also have to sit on top of moving equipment. So that was a really good application for robotics. So robots don't breathe in the same way. We can put some filters on there and they're totally fine. And now this person doesn't have to wear both a respirator and safety gear and hearing protection. We just put a robot in there to sit over a moving conveyor. So that was a really, really good one.
Very awesome. Okay, sick.
Wait, do you have anything, Joe, for you besides the freezer application that you've done?
Um, I've obviously done some freezer stuff. Sometimes the quality of a pick, or like when I want to make sure I have maybe a chain of custody or something like that. When you automate it, you get this kind of side benefit of the machine does what I tell it to do, and I know that it picked that, and maybe I have an imager on that setup, so I also have a picture of me doing that, and I have a whole
Mm.
transaction history of me doing that. So like sometimes we are automating for quality, And it's not super common. It tends to be on higher value goods or when accuracy of a pick or a process is super important. You don't want to cross two orders. Maybe it's medical or maybe it's like something that's highly regulated. When order accuracy is super important, uh, it might be something where hey, let's go ahead and look at automating this. If a person could accidentally miss something, but a machine wouldn't miss it, then that's a great use case. Machines can, with machine vision, check out a lot of data very, very quickly, and they're typically not wrong. And if a person's tired, I've read labels incorrectly. I've skimmed, right? I definitely did it in school. Yeah, I got most of it. I didn't get 100% of the serial number. All right. Or if you have to hand key a lot of information very quickly, a lot of that's vision related automation. But yeah, sometimes it can have an excellent payback for customers. And the craziest one, that like the piece of automation that sounds the dumbest,
Yeah,
but
what?
always has the best payback is corrugate trash lines.
Oh, yeah, true.
There's
Yeah.
nothing worse than like moving gaylords of cardboard across a warehouse all day on a walkie. Like it is mind numbing. You can't wear headphones because you're on powered equipment, right? You've got cardboard dust all over you. You're probably going to cut yourself a couple of times with cardboard, right? You have
Yeah.
to get a knife out and break it down constantly. Yeah, you put it on a trash line and it goes right into a baler. And mathematically, like it's one of like the most like almost every time it has a payoff. And it's not huge, right? But yeah, that's the one. We'll always start with that one.
True. That's one that I forgot about. Yeah, that's a good one.
So we talked about some awesome like times to do it. When would you not automate something? Like what are some situations, what are some scenarios where you're like, well, maybe you think you should automate that, but probably not a great deal.
A good one to not automate is when you are having that person or right, you're looking at a task that a person is doing and we want to move it to a machine. If that person in that task is making a computation or a judgment call specifically, that is one that automation may be challenged on. For example, if you have 3 or 4 different size boxes and it's not specified, uh, there's not like a perfect formula about what types of products go inside the boxes. The person basically chooses, meaning if they pick these 3 items, they may pick box size B or something like that. And there's no way to make it more robust. And you're simply relying on the judgment of a person. Your automation may be more costly and more complex than you'd think. So if it relies on a highly trained judgment call, it's usually a bad time.
Yeah, I think that's a pretty good example. I think we're talking about is like containerization. So a lot of WMSs will have a containerization algorithm. They'll say, hey, you need box C. When you see a whole bunch of operators throwing box C out and grabbing box D because you got a bad piece of data, or it's a puffy jacket and it fluffs up, but you can get into the box and eliminate all the void, or right, whatever the nuance is. Nesting funnels. I've done some auto parts stuff, and those like nobody ever got those right. Yeah, that is an excellent one. What one we see a lot is it's really a juice isn't worth the squeeze argument, right? Like you can, with enough time and money, you can automate anything. And I think that anybody in our
Right.
industry has heard that phrase before. Like the longer I do it, the more accurate it is. But stuff like there's a lot of automation solutions out there for full pallet movements, right?
Mm,
But sometimes, depending on the frequency that you do it and then the way that you have to interact with the loads, you're just not going to beat a forklift driver sometimes, right? If I
yeah.
have to go up and I'm just going, little point A to point B, and I don't have a lot of volume, like it might just be the most value like friendly to have an operator do that, especially if they have to put it like move through a really dynamic environment where they need to do it at
Yeah.
speed, right? Or that operation might change, or if there's a judgment at the end as to where to put this thing.
Yeah, there's like that automation is not the greatest yet at fuzzy logic. So that's a judgment call. The fuzzy logic is more of a mathematical term that it floats around.
Mhm.
And it's that
Yeah.
in math, right? Uh, Humans do fuzzy logic very, very well. Like I always tell people, you do calculus every single day in your head. You just don't call it calculus. You call it eyeballing it or feeling it. So in those cases where somebody's feeling it or eyeballing it or making that judgment call, typically automation is going to have to really be at sort of the tip top of where we are inside of the sort of automation world to do well. If Additionally, if another good place that automation can be a bit overkill is if you can change the behavior on the input, you don't necessarily need the check on the output. What I mean by this is many of my robotic systems are palletizing. It's very straightforward. People tend to ask me, hey, Danielle, does the robot know when we change the box size? And I go, no, not typically. We can add that automation. That's a vision system. That is something that we're going to have to program. We're going to have to test. It tends to be expensive. It tends to have okay rates of verifying it. And I say, well, what do you guys do right now when you change over a size? Oh, we have a binder and we have a standard operating procedure. When we change from 100-ounce to 200-ounce bottles, we have to change the bottle, change the label, change the filler, dot, dot, dot. And I go, and then you know what you should do? Change the robot. Like, you're already doing this changeover process. Why rely on a very, a rather expensive piece of automation when you can simply tell it? If you can train someone to do something blind, better. Better than having to put eyes or vision on some sort of automation. That's why I would say, like, blind robots are better than robots that see. They're repeatable, they're cheaper, they're more robust. So anytime you can remove that judgment, which usually involves your eyes, that's going to be a real win for at least the dollars and cents.
Well, yeah, I mean, you could replace $100,000 vision solution with a mouse click, and you need a mouse click 3 or 4 times a day. Like, man, it's really hard to justify. But the vision system is cool. Like, it's
vision. It is outrageously cool, and there's a difference between cool. What is like? It's cool, expensive, and like robust, right? It's like kind of the opposite of like fast, cheap, and
good.
Good. Yeah. It's kind of the same thing. It's like
me too.
Yeah. So I would say anything that you could train someone to do blind, even better. Best place for automation. I know that sounds very weird, but we really don't realize how many judgment calls we're making with our eyes and eyeballing things until you start putting automation into a process. It pops out really quickly. Something as simple as I had a customer I just did a bunch of systems with. They have a box that has a cutout on one side. Mm-hmm. So they were manually palletizing, not a hard thing. The case packers upstream, they face each other. So the one guy, it's easier for him to send the box down straight, and the other guy, it's flipped around 180 degrees, right? Not hard. When we put the robot in, I was like, hey guys, you have to make sure that the cutout is always on the left. And they were like, what do you mean? I was like, there's no box turner. If we try to keep this in sequence, then I'm going to have to hold you to a perfect sequence, and the robot can't see, and we're going to have to add this vision system, and it's like a whole mess. And I was like, you can just turn this box around so it's always to the left, and I'm going to put a sign there for you. Everything will be better. So there's some of that.
That's an interesting thing. A lot of times, and it's sort of like it's part parcel of like what we do, but it's more obvious in a greenfield system, but we force the environment to be like perfect for a set process, right? So you're designing a solution, you look at the data, you design a process, and then we start building technologies, and we make these environments that work great for these technologies. And it's because it's a lot less expensive to have this technology operate in a kind of a blind robot way, right?
Yeah.
And then you put it in an environment it doesn't like, and it suddenly doesn't work so good.
Yeah.
So another kind of interesting one, or kind of note on automation. This isn't necessarily a to automate or not to automate, but definitely a big thinking point is how does it scale later on? So you put it in day one, that's cool, or you design it for year 10, but what about year one? Can it scale up and down? And if you put in a monolithic like system, what then? Like, is it going to be a problem in the future? We get into this a lot of times with like large scale ASRS
stuff. I was going to ask, Yeah, how do you typically handle like a volume increase? Let's say it's the system's been in for 2 years, and then they're like, oh, we just won a huge contract. It's like, how do you handle that?
So when you're initially designing, you try to learn as much about the future as possible. So you're looking in the crystal ball, and you'll only ever be so successful with that. But you try to find as many future scenarios as you can and build those in. I will say that like working, we kind of went pretty heavy into like robotic style technologies. So like a robotic sortation or robotic based ASRSs, they are far more forgiving when talking about scaling. Like typically the storage and the throughput scales independently, and they'll also typically scale much lower. Sometimes when it gets extremely fast or extremely big, then the kind of classical equipment starts to look very, very good. But I don't find a ton of applications that are at the extremes. I find a lot of folks that are starting and then they have this growth plan and nobody knows about the growth plan. And these robotic systems tend to be the most flexible in that regard.
I know what these are, but I'm asking sort of like, but when you say robotic ASRS systems, like what are some examples of that per se?
Uh,
Like,
yeah, so like an exotech is like an awesome example. So it uses robots to function as every moving part of a storage solution, right? It brings the bin to the operator. It takes the bin and stores it in the rack. It checks. It does everything. It's just this robot, and that robot is the piece that can scale, right?
right.
Versus something like a mini load, like it's a crane based system. So there's just one kind of big crane, and it runs up and down this one aisle. And it's always one crane in one aisle. Sometimes you can have two cranes in an aisle. It's very complex. It gets a little exotic, but it doesn't scale the same way. Like if you want more throughput, you have to add a whole other aisle, right? If you want more storage, and maybe you can make it longer, but that crane is already that length, and so like the way you've planned for the future with those type of technologies is a lot different. Now they have this is always like a nuance thing, and so in every application we end up having to like look at all the different solutions and figure out which ones fit best because a robot is a certain size, so it's got limits, or ours do. So we have to figure that out in every individual case. And a lot of times we'll put forth many different options to a customer and say, this is how I would scale this one. And this is how I would scale this one. Just for what it's worth, like keep that in the back of your head as we go through like this kind of final process here. But yeah, the robotic ones, like if I need to add a little capacity, I add one little robot. And that is infinitely less expensive than one aisle of cranes. I had one other kind of like line of questioning here, which was like, what's kind of the new trends maybe in regards to like what's going to open doors to automation or robotics? And I think that like robotic based like type of like sortation storage systems are kind of on our side. That's where like we're seeing a lot of success in that regard. As far as like the kind of like robotics side of it, like arms manipulating things, like machine tending, the work that I think you guys have been pretty successful with. What's going to break you into some things that were traditionally not something you'd put a robot in? Like what are the new technologies or what are the new methods?
A lot of the improvements are really coming in, it's going to sound crazy, but deployment time. And that'll be also deployment time and cost. Those are very straightforward ones. Cost always, right? The lower the cost, the easier it is to implement.
Yep.
I work for a company right now, Formic, that does robots as a service, which is basically nearly nothing up front until it starts producing. So we sort of remove that CapEx portion of things and change it to OpEx. So that's the easy one, right? That's cost, is how can I remove you taking a gamble on putting in a piece of equipment. There's, what if you're wrong, right? What if it doesn't work? What if it's not going to perform, et cetera, et cetera. So
what if you don't
that's
want to
really,
wait 12 to 18 months?
exactly.
Right? Like that's a
So
big one for us.
so yeah, the most straightforward is the lower the cost, the easier it is. So that makes a lot more sense. But it's not only lead time. So lead time is like between when you place the order to when we show up with the thing.
Right.
So getting a lead time to be shorter and shorter and shorter is rather important. Often when people show up asking, or customers show up asking for automation, it is typically already painful and too late. So they're typically already struggling to find somebody. They're already in pain. They're already behind. maybe they have come to automation because of, hey, we ended this quarter and we did not make the targets, or hey, we're not able to fulfill these orders for our customers, or something like that, or hey, our overtime rates are astronomical because we're having to run 10-hour 12-hour shifts, with less people in order to get the same rate. Typically it's already, like, basically people are already bleeding, right? So the faster that you can get a solution in there to help stop that bleeding, or lessen the bleeding, the better. But rapid deployment is really something that, especially in my world, is becoming sort of the most critical piece of this. So not only can we show up with a robot system very quickly, but can we put it in and get it working very quickly? When I first started, we would typically be on site for like a week to do mechanical, and then a week to do electrical and like startup, and then sometimes even a third week in order to do the testing. Now I can say to you, hey, Joe, for this palletizing application, I can get it up and running in a day,
That's
maybe
wild, by the way.
it's wild. I just did 2 robots in a week, one in Washington, one in California, and I need to stay there for at minimum 2 days of production support. So that means it's running. So I simply had installation one day, and then running production at the end of the first day, and then 2 full days of me watching, and them actually, the client actually running. So I'm sort of fixed on 3 days. But if I didn't have those 2 days of production support, it really could be a 2-day adventure. So being able to say, hey, this is your one line you run of this item. If you can allow me to have 1 day of downtime while I put this into your brownfields, and you can start it on the Tuesday, right? So Monday I'm installing, I'm in your way, cool, fine. Tuesday, you are running it with your product. That is a huge barrier to remove to people. So now they don't have to go, oh,
I can't be
our
down.
plant is,
Yeah.
yeah, our plant is already bleeding. We're already behind. We're already running overtime. How dare you ask me for a week of downtime, where I could say, I just need one. And then it's a lot more palatable for people to say yes to these things. You take the cost and all that type of stuff out it. And then if I can say, hey, Mr. Customer, I can have this in 4 weeks, 2 weeks. I need a day of downtime for some simple applications. Then you're like, yeah, let's do it yesterday. So that the rapid precision deployment I have been finding is really, I mean, this is what I'm specializing in at this moment, so it's very forefront on my mind. But that portion of things makes it easier because, I mean, Joe, I mean, your stuff is much longer lead time, much longer scale up because it is far more complicated. But have you ever been in a situation where you've pitched, your beautiful design, and then you do that slide at the end that's like timeline,
Oh yeah.
and then people's faces just tell me more about that.
Yeah. All the adventures on like Microsoft project, like can we do this concurrently? What does that mean? Is the site engineer going to lose his mind? Right? Like we do a lot of like very large scale systems, and the changes are pretty sweeping, and the paybacks are huge. But it is still difficult for a customer to have to give up 80,000 square feet of laydown space for a monster system, right? And to juggle all of their production and purchasing and logistics while you're putting that system in. So every week you cut off by being more and more creative, or like being more aggressive with vendors and suppliers and shipment times and all that, or extra crews, can be worth a ton to the customers. But nothing we're doing is approaching a 1-day robotics install. Like it's pretty excellent. When someone says, "Hey, I got to do it really, really, really fast," we'll often select different types of equipment. So
Okay.
and Hy-Tek does a pretty good job of trying to be agnostic. So we look at several different conveyor vendors. Let's say that's like a sorter system. We want to do something real quick, so we'll call all of our friends and say, hey, who's got some space in your production schedule? But sometimes, so like some equipment, like a Best Connect type of system, you can install them very quickly. They don't have the same functionality or customization options as maybe like some MHS equipment. But you can slam them down, you wheel them in there. And you and I think one of our past employers have designed a number of these systems. You wheel them in, you hook them up, you plug them into maybe 110 power, and you're off to the races. And so they're pretty fast to install, and oftentimes they might be stocked at the manufacturer, and they're pretty good. A little shout out to Tompkins T-Sort. The way that that system is engineered, it's essentially tables on wheels. And so provided they have a little bit of lead time to get it there, but once they get it to site, they can put it together pretty quickly. And interestingly, they can reformat the system in certain circumstances pretty quickly too. So like pretty quick build, pretty minimal floor spec kind of stuff too. The more like high end the automation, it tends to have more environmental specifications along with it.
Yeah.
And those tend to be harder to hit. Like your floor has to be very, very flat. So some automation, when you have to have a super, super flat floor, it's going to take time. You got to get the concrete guys out. You got to have really excellent measuring tapes to make sure it's real flat. You got to have somebody who can read the spec, which it sounds like it shouldn't be a big deal, but it is. So those things take longer. And if I can bring some conveyor in with casters on the bottom where it doesn't really matter, that could shave months in some cases off of a project timeline, which is wild.
Just wild. Yeah. Do you find that most of your sites are greenfield, so like brand new ones, or do you function inside of the brownfield where you're disrupting production often?
Both. Yeah, we own both. It's obviously really cool to do a greenfield because you're taking the process all the way back to square one, and you're designing this is exactly what we kind of want. You can dial everything in. Sometimes with brownfields, you have to make some compromises because of what is existing or what you can do. The laydown space, like how long do I need to have the space blocked out for? So we do a lot of distribution center work, and they buy a big building because they need a big building, not because it's cool to have extra space. So I need 20,000 feet of laydown space so I can construct some rack. Like that's hard to swallow. In a lot of circumstances. And so the faster you can install it or if you can figure out the install schedule so that you don't have to have it as long, that's a big deal. And then, obviously like just system downtime is a big one. We try our hardest to design things that don't have to take the complete system out. Right. And then, every controls engineer loves like a cut-in weekend, right? We do them all on like if I have to take it down, when's the least painful time to take it down? And then you try to schedule around those. I've done a lot of Saturday, Sunday cut-ins, and it's not my favorite day of the week, but
no, it's rough. It's rough. It's hard.
Yep.
Truly, I did a speed run, and from crate to power up robot was 4.5 hours. It was insane, and there was only 3 of us. It wasn't like there was like 10 dudes. It was me, an intern, and 1 programmer.
They just had like the power drops were sitting there, and the data drop was just waiting for you. And
power, air, and Ethernet were dropped. We drilled concrete. I did the old drilled vacuum combo, and epoxy down and everything in a pretty short amount of time.
Okay, well, Danielle, thank you very much. I think this is a pretty fun conversation.
Yeah.
A lot of these are questions that we routinely get asked when we meet with customers. I'm sure like you have kind of the same experience in that regard. Any closing remarks?
Truly, I say boring is if you are walking through your warehouse and if you can imagine either yourself or your kid or your cousin or your best friend, whoever you want to put your shoes in, if you imagine that somebody else doing that job all day, every day, and you just like kind of roll your eyes and go, "Oh, that could never be me. That sounds very boring." That is where you should go. Automation.
Right.
If you wouldn't subject your niece or nephew to it for 8 hours a day, or yourself, your younger self, that's probably a good place to be like, I feel like some nice people on the internet, Danielle and Joe, were like, we should do some automation. What about any closing fun sound bites yourself?
Yeah, let's just get rid of the boring stuff. We'll only have exciting things for humans to do.
I mean, it's true. People don't want to work the boring jobs. Nobody that I have interacted with in my past 12 years across the nation has said, we have so many people lining up to work here. Everyone, regardless of industry, location, or task, is like, really wish there were more human beings that would want to work here and show up and do this work. I've never had anybody say, we just have so many applicants. That's never been a thing someone has said to me.
I do
Yeah.
a lot of hybrid, like automate just a little bit of that process. Those tend to
Yeah.
have a really high return. It's kind of the same concept of mixing two different technologies. So we'll have an ASRS, and instead of doing like discrete picking, we'll pair it with a sorter so we can do batch picking. So
Mm.
we're having both these machines do the thing that they're really, really good at. And it tends to make the system less expensive and more flexible,
Yeah.
which is,
That's
yeah.
Joe, I think that's a really good point, is like let humans make judgment calls, let them be dynamic, let them sort of uh, have that fuzzy logic in those moments, and then let the automation do the dull, dirty, repetitive, heavy type of things. And if you
Oh, it's
combine those two,
yeah.
right? If you combine those two, you'll be good. Now, if you flip it and you're just like, okay, human being, pound rocks, and then computer make these fuzzy logic, high judgment, kidding, nesting, that would be the opposite of what you want to do. And if you could imagine that, that's that the combination of humans and automation, I think, is often overlooked. So I think that's a really good point.
Really.
Yeah.
All right. Well, thank you very much, Danielle. It was an excellent
Thank you, Joe.
conversation. We'll talk again probably in the near future, and have a
Yeah,
great
we'll
afternoon.
come up. I know we had some more topics. I like have my little notes here, with my little smiley face. Yeah, definitely talk soon. Always good to see your face and be a nerd with you. So thank you so much.
All right, later.